All right, yeah, we are live. So last time we wrote a test case for the search string for finding like a very simple basic test case, right? And what we left with is we were thinking whether is there anything to refactor, and then what's the next step that we can do. So is there anything to refactor in the current code or the current test case so far from anyone that we haven't done so far?
Not much. I think, yeah, instead of compile, we could do a must compile to get rid of the error handling. But that would be a panic statement ho jayega if it doesn't compile.
Got it. Okay. And one was about error handling from scanner. So I think scanner also has the API has scanner.error. That is something that we could do.
Okay, so could you repeat that? I didn't get it. Scanner has something called?
Yeah, so Golang, the scanner API, there can be errors while scanning.
While scanning, okay.
Yeah, so we will probably have to check if the scanner.error is true, and if yes, then what do we do?
Okay, yeah. So for that, I think we should.
So it is typically, so again, that's where
Yeah.
if you Google, I guess that from Stack Overflow, you can find a good example of this scanner code base, which handles the error also. Let me figure out.
File.close can also throw an error.
Can you try typing? Can you try checking what are the APIs for scanner? Right, scanner dot Cooper. Yeah, if you do it, scanner dot. Is there an error? Then what happens if there is an error?
Error returns the first non-end of file error that was encountered by the scanner.
Yeah, so most likely this. What is the ERR dot error?
It's the string.
Yeah, so what Rahul has sent, right? Something like this, that this is what we should handle uh, in the chat for this meeting. And the way to handle is just whatever is the error, we just pass it back to the client because we can't deal with it anyway. So if you say if scanner.err error not equal to nil, then return the error.
Yeah, so inside the for loop, right?
No, this is out after the for loop. Because again, now this is where I'm a bit sketchy about this exact API, which is where whoever is driving, right, they should read more about documentation, and we could have done that as well last time, but we couldn't do. So the idea is read through the documentation of the API, figure out what's the idiomatic way to use it, right, and ensure we use it that way. So if scanner.array is not equal to nil, actually assign it to some variable so that we can return that variable.
Yeah, so you want me to return a constant if scanner error is not
so nil. If you look at the Zoom meeting chat, you can just copy paste that code for now. Done.
Yeah. So something like this.
Correct. So if there is an error in scanning, this will return error, and then we just return that error.
Yeah.
So we return, instead of log.fatal, we will return the error with nil and error. Okay, so this is another error handling. We can quickly run the test case to see if things are failing, passing. We now you might be okay. How do I simulate this error? Right. So probably there is a way to simulate it. We won't go into it right now. And this is where having now, if this was a real project where we could, and we don't have a time limit of 1 hour, we could actually go read the API, understand the use cases, what are the possible cases in which scanner can throw error, how can we simulate this test case in a, how can we simulate this case in a test case, if we can, should we, these are all the questions that we would like to answer. What I would typically do, my take would be that, look, this is a standard API. We are not testing file related functionality. Like we are not testing the scanner API. We know it works because it is part of a standard library, right? As long as we are using it idiomatically in a correct fashion, then we are okay to not test this scanner error. But the code should still be there. So as far as the test coverage is concerned, the branch coverage will be less because the line number 37 will never be tested, right? But what we should do is we should nevertheless read the documentation and figure out that yes, this is how scanner API should be used. Right? Even if we don't write a exact test case for it, it's okay. All right. So for today, what do we have next?
So yeah, in yesterday's or the last past session, we did discuss like how we should have multiple test cases that would check for nil matches, and then it would check for one match or many matches. And we just stopped the past session with one match, and I'd like to improve on this test case to show zero single match and multiple matches.
Got it. Okay. Yeah, makes sense.
So I'll be attempting to do a table driven test.
Yeah. So if you want to at this point copy paste, I believe, I mean, I'm okay with it. Like others, let me know if it's okay, because now this is
So
really
others
the
can actually like suggest.
Yeah, I think that makes sense. No?
yeah,
It's not
because this is
necessarily.
purely just syntax now,
Right.
and that it's okay to copy paste because you've already written. If you hadn't, then we would anyway have been waiting, right?
Yeah.
So that's okay. We can actually use this time to do more stuff. But I hope the flow is clear, right? Why, like we started with one test case, and then we are saying, okay, what all are the other test cases that emerge? So typically the red green refactor cycle continues on. Like once you have a red test case, then you make it green and then you refactor, which is what we did. At the end of that cycle, we again try to identify, okay, now what's the next thing we should do? Right? And typically because it's a test driven development, we typically start with yet another test case. And the test case, and that is where the initial time that we spend, right, in the discussion on brainstorming, like identifying the problem, breaking it down into test cases, API interfaces, return types, all of that becomes super important because it just is a good milestone that tells us what's the next thing we should do. So in this case, as Suraj has pointed out, it makes sense to add these test cases for 0, 1, many case. So I believe we will have to create a file for having a single match, having multiple matches, or we can use the exact same file but with a different search string.
Yeah. So something like that is what I would try to do here. So in the first test case, my search string is non-existent, and the file path is testdata.txt that we have here with these two strings. And then I've done a single match where it's search string fully the same file path, and then the expected is an array of string with just one match. For multiple match, I have changed the search string to search and just the underscore with the same file path, and the expected matches are 2 because both the strings in the file have search underscore. So in table driven tests, we're supposed to do iteration over all the test cases within this test cases struct. For that, it's a simple.
Are these test cases same?
Are the
Are these test cases same? The no, not. I mean, I think actually the input to the test case. My bad.
yeah,
Input to the
the
test
input to
cases
the
is same.
test cases is the same for the first three, and then for the non-existent file path, I've deliberately changed it.
All right.
No, the input
And
is
are we?
different, right? I mean, by input, I mean the value is different for each of them.
Yeah. So what I'm saying is, have we copy pasted it from somewhere else?
No, I had them ready before the meeting.
Oh, okay.
We just pasted them.
No, what I'm trying to say is, are we, if you're using the same kind of input for different test cases, why don't we set up do a setup or a tear down kind of a thing here? Or do we already have it?
You mean like for each test case, I should build a .txt file, and then after the test runs, I should delete it, something like that.
Yes, yes.
Yeah, so that can also be achieved where I just
Okay.
uh,
Probably we can take that up maybe later. For now, just finish this. Yeah.
okay, yeah.
Yeah, so to answer hopefully your question, the input is different for each of the test cases. It's not the same input. Like the file is the same, but
Yeah.
the way
Hmm.
Suraj has cleverly done it is the search string is different for each test case, right? In the first one, it doesn't result in any match. Right? That's a non-existent search string. So the non-existing
Okay.
word does not exist in the file, test data file.
Okay.
In a single match, there is a search string as a word. It only exists once. So that's why it will return a single match. And that's why the expected result is also that single line.
Got it.
So this is purely hard coded based on the table, like the test data that we have.
We were using error.
So for those who have not written like table-driven testing Golang, the idea, while Suraj you implement this, the idea is look at our API. What does it need? The function is called search in file. It needs a search string and a file path, and it returns some value, right? So these are the three things that we typically will typically pass or verify on. So the first two things are what we pass, the search string and the file path. And whatever we get back, we verify it with the expected result. In this case, we are also getting an error. So now, which is where the line number 61 to 64 test case, we'll talk about it later as to what happens in that case. Right? But let's first complete the test case.
Okay, so yeah. Should I run the test and just explain it from there? Yeah, so it fails for this one. 71. Yeah, it'll do that because we gave it a file path that from where the file does not exist. So it's failing here. And then it'll consequently fail here as well because it's not getting anything from there. So
yeah, so I think the expected in that case is nil, right? If we say nil,
yeah,
then it will actually work.
yeah. Just the one where the error is because the file does not exist.
Oh yeah. So correct. So this one we will have to. So now, any ideas on how we can fix this test case?
We can add an error field in the structure and then return the same error and then check that over here in line 71.
No, actually, with this example, non-existent file, so the function is expected to be written an error, right?
Yeah.
So that needs to be handled as a part of the test case. So instead of just checking expected one, if that test example itself needs to be, if it is expected to be written an error, so we may need to have one more field in this structure,
like this.
whether the error is expected or not.
Yeah.
And
Like a
then
test description or something like that, where we can decide if it is positive or negative test, and then while checking for error is not equal to nil, we should also check if the test case is negative. If the test case is positive, then error should be nil. If not, then fail the test case, something like that, right?
But it could be
Uh,
negative in multiple scenarios.
right. So we
Yeah,
should-
but yeah.
So I did not understand why the error expected is nil in case of file is not present. That should be a valid error, right?
No, so error expected. So this expected is actually the matches, not the error itself.
Okay.
Yeah.
So expected parameter we are checking with the whatever output we are getting from the search in file
Search
function.
and file function.
But that function returns the error as well.
Yeah.
And here we are simply failing that test case if it returns the error, but it should not be the case.
Yeah.
The test case should be passed for this kind of scenario where the file is not exist, then it is expected to return the error. So here we need to check that condition.
Yeah, here I think we should add another field itself to this where it's just a string or a bool maybe. And then I will do
So yeah, before we implement, like, what's the thought process on that? How will be this bool field?
yeah.
This is going to indicate what?
So this will indicate if the test case that we have defined here is expected to throw an error that we know. Like so here when I'm giving a non-existent file path, we know that this test case should give us an error and the expected should be nil, but the error should not be nil.
Correct. So just like we, I mean, one idea, this is maybe one idea, the test description, I believe, but a Boolean name should always be
Yeah.
something that tells us whether it's true or false, right? In
Yeah.
right? So the other option is can we, just like we have expected, which is an array of string, can we have expected error? And in case of
Right.
positive cases, expected
Yeah.
error can be nil. And in
Nil.
case of negative, the expected error will be an error string that we expect it to contain.
Yeah.
Or even the data type can be an error itself.
Correct.
So data type, if it's an error, what happens is we'll have to do an error.new, right?
Yeah, or we can do error with E capital and like we
Yeah.
can convert this into string and just compare that this the string contains the no such file or directory or permission error or all the other 100 types of error that we talked about last time. Really up to us. Like it can be either error or string, because ultimately it is going to be converted into a string. So yeah, if you want to make it a string, that's also I guess fine. But let's see. So here, if we make it error, then it is going to be nil here, right? It may be better in my, like I'm thinking it may be better to make it a string actually.
Yeah. So the issue is that if I do a error.new,
Errors.new, I think.
yeah, errors.new, this will give me a distinct error value every time I call it. So if I have an errors.new here and then I have another one, so what my test case, if it does give me an error, even if the text within it is the same, it won't pass because it gives me a distinct error value every time.
Yeah, so it is like two errors created from errors.new with the same text are still different.
Distinct. Yeah.
They are not equal to each other.
Yeah.
Yeah. So in that case, maybe it makes sense to use a string. Then we might also need a positive negative flag, but let's see if we need it or not. By default, it can be empty string. Yeah.
Here I can have it as I think it's something like could
Yeah.
not.
For now, let's write like no such file or directory or something like that in this. We'll anyway have to figure out the exact word based on
Yeah.
failing test case. So if you want to just write file, that's fine. Yeah,
We
error
can
or
write
whatever.
file error.
Yeah.
And we need to send this string from main.go.
Actually, no, because in main.go we are handling the error like this, right? Like whatever os.open generates, that error we are passing
So
through the.
instead of that, we could send file errors.
Yeah, so you're saying that instead of error, it should be errors.new and then whatever is a
Yes,
constant value or something like that.
right, because that would be what we get. Then compare with this one.
Okay.
So in Golang, typically the convention is to just pass the same error. Typically, you don't want to wrap the error with your own value unless you are trying to hide the error or make it more user friendly or whatever. That's a typical convention. So because when you wrap an error with your own error, you're adding more complexity or more cognitive load on the reader as to, okay, why is this wrapped? Like it's just a file error. So why are you wrapping it into another error type, right? What is it that the original error that is trying to convey, which is not covered, or other maybe the other way? What is the new error that you are trying to? Okay, what's the purpose of new error really, right? It doesn't serve anything apart from just wrapping and making it easier to test. Right? So in that case, if like I would be personally, if you ask me, I would be like, why do we have to go against the convention? Because typically the rule that you should follow in the code is principle of least surprise. What that means is any code that we write should be least surprising to anyone who is familiar with the language, right? If we make it more surprising, that okay, why, like, oh, this is weird, this is surprising, this is new, right? Then we make people think, and that could introduce more issues, more errors, more bugs in the code. If we follow the convention there, we are staying in those guardrails. So that, given that, I believe it might be a bit overkill right now to wrap this error into our own errors.new and then return that and
Okay.
So yeah, I'll just run the test and give us what the error is supposed to be.
yeah. Are we comparing the error though? We are not, right? We should
We are
compare.
not, yeah. Error not equal to nil.
No, it is error is a
Yeah.
string, right? So
Yeah.
let that be like that. Error not equal to nil.
Is there a way in Golang to check the category of error? Error dot as or error dot is, something like that. Is there? No?
Yeah, we could do type of, but again, so let's see. There is a different way I have in mind. Let's see if I'm able to articulate, right? So let's check this 75 and let this be as it is, right? If error not equal to nil, right? Makes sense. And then if this is if there is error is sorry, if there is an error here, that means the function has failed. Now this is where we need to compare the expected error with the error dot err or error dot error, right?
Mm-hmm.
So err dot error contains the expected error, something like that. So like strings dot contains.
Yeah.
Sorry, someone had a suggestion. Yes, I agree with Rohan. The t dot run. Okay, yeah, let's implement that as well.
like the substring. So this can be either ways, right? It can go both ways.
No, it is the one way, right? Because substring is not transitive. Like if A is a substring of B or not transitive, what is that property called in mathematics?
Uh,
Cumulative or associative? I don't remember. But the order matters. No, it should be other way around. Error contains this substring. Right? There's a S string, which is the main string, and then we're trying to find the substring in that.
yeah,
Right. If A contains B, then it's not necessary that B contains it.
Correct. Yes, that's whatever the property is called. That.
yeah. So this is
So if this not, then we fail the test case, saying we were expecting this error, but we got some different error.
is this visible?
Yeah. So we got the the test case is now failing for the right reason, right? The file error is what we got, but yeah, all we need to do is the no such file or directory. If we add there, it should work ideally.
You can
Others?
just have, then remove the file name and that one. So it's a substring, so that should be fine.
Could you repeat?
Yeah, you can remove that open testdata.txt
Yeah.
and just have the no such a file or directory. So that should work.
Yeah.
So like others are is everyone following so far? Like any thoughts? What we should do is what Rohan suggested. We should implement that also. Again, it's a matter of like running, like knowing Go idioms properly, where we do this as a t.run so that every test case runs in its own test case. Every example runs in its own test case.
So those all concurrency parameters will apply if we need it.
Not necessarily concurrently, but they like right now whenever there was a failure, right, we had to figure out, okay, which test case actually failed. We didn't get that information very clearly. We knew that the others are passing, therefore we knew the fourth one is failing. It was very clear. But if there are like other examples which are very similar, then we would like to know which test case failed really with a very clear idea. So that is what the t.run allows us to do.
Okay.
Are you aware of this, Suraj, or do you have the syntax handy? Do you know the syntax? We'll have to Google it.
Should be in type T.
I can help. Like,
Yes, please go on.
As a subject of the name.
can you go back to the base code?
Yeah.
Okay, so like you have given names to each test cases, like in the comments, right?
Yeah. So I just
So,
put that to
yeah,
test name or something like that.
yeah, you can. Okay, and now in the for loop you can.
You can just convert your comment into the yeah, pretty nice. Do you guys know multi-select in Sublime or also text editor? If not, that is a shortcut that you should definitely learn. This will save us.
Yeah, I mean, you can, in VS Code, you can highlight a word,
It's
select
very
all, and then press
difficult to-
Control D.
If it's
It
difficult
will
to
select the
describe,
next.
like I can show by doing it, but I don't know how to explain on a
Okay,
camera.
You can even hold on Alt and then click wherever you want to bring multiple.
Right.
Oh yeah. So yeah, like I would say run the shortcuts, everyone. This is super like productive.
And then I do.
Yes, and first parameter will be the testing. Yes, and and there will be a closure like type func. VS Code will suggest you. Yes, it's the second one.
Yeah.
There is also some shortcut that I used to in some text editor where anytime I save my code, it would automatically run the test cases.
Okay.
That was another thing that one can explore.
But that just becomes, yeah, anytime you save it becomes too.
Yeah, so the reason
Because
now
if you have an auto save.
I'll now have IntelliJ like preaching. So IntelliJ, what it does is it by default saves your code. You don't have to click the Control S, Command S, right? But if you forcefully click a Command S, Control S, which we are used to by default, then that is the time it runs a test case. So it has the best of both worlds.
Clean, I think.
What does this command do? Sorry, I'm not aware of it.
So if I had run the test case like within 2 minutes or something, it will just give me the cached test result, even if I change the test case in between. So I just clear the cache and then I can run the test again with new.
Why is this a feature built in the wrong way? Like,
No, I think if you don't change the test cases, then it will return.
Something like this. So I did a t.run only, right? It's not changing the test input per se. So it'll just give me the cache test instead of running the test again and giving the result.
Okay, this for me, this is a violation of principle of least surprise. Like it's a very surprising thing that the test editor does.
एग्जाम में अपना आपका टेक्स्ट बुक लेके गए वैसा लगता है
What did it work or no? Like
Yeah, it did work.
No, but why don't we see all the 5 test case names? That is what we should see ideally, right?
Yeah.
It will show you like if the test fails.
If I do the package test.
No, like
can you fail one test?
Then it will show.
Oh, okay. So something like this. If I
like change the search string, then it will
Try code test -v.
Yes, minus
still
V.
क्या?
वो
Yes,
both
yes.
Correct.
Yeah, एक second. So yeah, this one, right? Yeah,
Nice.
so this shows the test names that we have.
Oh, nice. Yeah, so we can get rid of the last one that we just added, dummy one.
Yeah.
And anytime we have a working test case, what do we do? Yes, so let's commit the code.
Does anybody want any changes in the final code? Should I remove this part?
Yeah, I think we should.
And then here I added the scanner.error. Even this, shall I comment?
Yes. Yeah. Makes sense. Nice. What's next?
Yeah, we did this part like number 9.
Correct. So after like what 2-3 iterations, our first story is complete. Right?
Yeah.
So you can see it takes a lot of time to do test-driven development, especially if we are new. It is going to take a lot of time. Yeah, but as we do this more and more often, most of the things will come natural to you, and you will almost like write code like wizard, right? In some ways, things will come to you instead of you having to struggle through API design interfaces, all of that. Like this is just a matter of practice. So and that's the whole purpose of this programming session, is to practice this with everyone, right? And that way everyone gets a chance to drive the session. So as a next step, we want to implement ability to search string from a standard input. Right? That's the next step. Now, how does one do that? Any ideas on, like, so far in the test case, like one challenge that I clearly see is in the test case, how does one wait for someone to write input, right? Because standard input means someone can, like, as a user is actually typing some input. So how do we write automated test case with a manual user interruption? It almost seems contradictory, right?
Yes.
Any solution to that? And I would again request Kalpesh or someone who already knows the answer and has already solved this before shouldn't answer, so that hopefully this gives other people time to think.
Do we want to test the inputs or just the function that is checking? I mean, the function can have an array of flags, and that we can probably test by manually providing the flags in the input.
Yeah, does everyone understand what Mohit says?
Can you repeat all these points? I didn't catch it.
Yeah. So if we don't want to check the process of providing input and just want to check the function that is actually searching, in that case, we'll send an array of flags to that function that we can mimic in the test case.
So our ideal function is something that should take in an array of string.
Flags. Huh.
Yeah, array of string, and then should give us another array with all the matched elements.
Right. So that array we can mock, but I'm not sure about how will you test this input.
But at the same time, so if you look at the utility, whenever we say that search the string from the user input, that means the function whatever you are returning, it is not taking the array of inputs basically. So it returns give you a result immediately whenever user gives you the input. So it is checking whether that string, whatever input entered by user, whether the search string is present or not into that particular string, right? So it is, I think the function signature will be not having the array as an input because we are taking one string at a time.
Yeah, does people understand what Kalpesh is trying to say?
Yep.
Yes, I do.
And just okay, Suraj has dropped somehow, but if you look at the problem statement, do you think that's the behavior, or what's the behavior like right now, as purely as per the problem statement?
I think you provide all the inputs and then you get output together.
Correct. So what Kalpesh is trying to say is the streaming behavior. Like, do we want to do the matching via streaming fashion, or it is a batching fashion, right? So as per the problem statement, it expects it in a batch. It doesn't expect a streaming. So although a streaming would be really nice and interesting problem to solve, but currently we can say that, okay, to again keep things simple, we have kept it as a batch. So user will type in all the input at once, then the user will press some key, which is the command D, control D, in this case, the control character, to indicate that, yeah, I'm done with my input, which is how most of the Unix command behave, right? They have this control D or control C as an interrupt to actually indicate that, yeah, there is no end of input, almost like end of file, very similar to that. And that's the cue for the program to stop accepting input and then process whatever it has accepted so far.
Right.
Someone else wants to share the screen while Suraj comes back. What should I do?
I don't have the copy of the code right now. Mohit, do you have the copy?
Yeah, just a minute. Let me pull the latest one.
I don't think we'll be able to anyway complete or start implementation of this problem right now. But what we can do is brainstorm and figure out and agree on a solution so that next time we can implement. And I believe next time it is Rohan's turn who is going to drive the session. So again, if you want, Rohan, you can create this boilerplate yourself beforehand if you want to. That's also okay.
Yes, is the screen visible?
Yeah, thanks. So in the README, if you go, we have an
Mohit, can you open the readme?
Yeah.
So here the ability to search for a string. Here it says, okay, I'll accept all the input at once, and there is a control D, and then after control D is pressed, it will then figure out if foo is present in that. So in this particular case, because the problem is structured this way, what Kalpesh said is not the constraint. Like we don't have to do it via a line by line. We can use a string array for now. But if it were written such that anytime there's foo, it should immediately produce foo as output, then the program expects this to be done in a streaming fashion and not in the batching fashion. Does that make sense to everyone?
Yeah.
So also, why does it have to be a array of strings? Can't be a big string which is concattenated by a new line character. So
yeah,
the behavior is same as the previous, which is basically where you were reading a file and having a long string. It would be same like you would have a long string which is concatenated basically. Now, how do we do that? That's a different problem you need to think.
Correct. It's really up to us. Yeah, both are okay, and both are anyway reading the whole thing into memory, right? So right now, as we discussed way back in the first call, we are not worrying about files that don't fit in the memory. Like we are not going to worry about, okay, if my memory RAM is like 512 MB, and if my file that I want to grep in is like 5 GB of file, then our program is not good. It will fail. But that's okay for now. We will again worry about and talk about how do we actually handle infinite, like very large files that don't fit in memory and whatnot in the later like sessions. So so far what we discussed is there are two options, right? One is we can use either a single string with new lines, or we can use a string array where each line in the input or a file becomes a string inside the array, and then the purpose of the grep function almost becomes like a filter, right? There is like bunch of lines that come in and we filter out most of them. We only keep the ones that have the inputs, like the other string that they want to search. It is as long as that string is present, we allow that line.
Right. I'd like to add why we are using an array of strings and not a single string with new line, because flags provide you an array. This bars foo is like flag at 0, flag at 1, flag at 2. So at the point when we are reading the flag, we'll have to concatenate. We'll have to read from the array, then concatenate into a string. And then when we pass to the function, then we'll have to revert it back, parse that big string into single lines. So I think it's double work.
No, so in this case, line number 16 to 20, those shouldn't be accepted as flag in the program. They should just be input, right? Like the flag to the program is only foo. And an indication that there is more coming. Because anytime you enter like any Linux command, if you press enter, it assumes that that's it, like that's the end of the command. Like you have, it's almost like adding a semicolon, right?
Mm-hmm.
So any command doesn't allow, so only if you have input, then you can like that. So we need to figure out some way in which we can do this in Golang that it can accept input from CLI.
Okay, understood.
So what Mohit talked about earlier is that there are two ways in which we can do this, right? One, in the test case, again, we want to do test-driven development, right? So one way is to ignore how the input is coming to be, whether it's from file, whether it's from CLI, standard input, etc. We don't care where it comes from, and we won't even test that part. Right? So what we will test instead is just the bit that is core to the problem, which is the filter or the search functionality. So then what if we expand on that, then we are looking at saying, we are saying that there is going to be a function which takes probably a single string with new line or an array of strings. Let's just consider for now an array of strings, because that's how if I don't know what's the current implementation like, but okay, if we check, if we consider array of string, okay, it anyway takes a file path, right? So if we consider an array of string as an input to the function and a search string, so then what this becomes is there is no file path, because that's external to the core function. So this is not a core functionality of the program. Does this make sense to everyone?
We probably need to refactor and move this out. This compile and then matching. This one.
Correct. So one other way to think about this is, let's look at this function, the search in file function. What are the responsibilities of this function? Can someone try to articulate? Okay, what are the 1, 2, 3? How many responsibilities does it have? 1, and what are they?
I think 3. One is opening the file. Second is matching on it. No, second is reading from the file, and third is doing the matches.
Okay,
Yep.
so one, go on.
That sounds right.
Yeah, so if we want to combine the open and reading file into same, because think about them, both of them result in some similar error scenarios, right? Both of them depend on external factors, that is the file system.
Right.
Okay. So this is where now I want to introduce a term called functional programming, and I want to say that the act of reading a file is a side effect. Again, what you should do is then later go and read more about functional programming and what it means and all that. But the idea is that the core part of the program is actually the line number, say what, 25 and 25 to 35. That's the main core part of the program. Or if there is a single line in the program that is actually what the program does, that line is line number. Can someone guess what that line number is instead of
31. 31.
Yes, very precisely. Like that's the essence of this program. Line number 31. All other things is just ways to achieve that. right? It is all just implementation details. What the program essentially does is encapsulated in line number 31. If we are able to grasp this concept, we have really grokked like a bunch of like a lot of functional programming and really identifying core from periphery, which is a very important concept that one should learn. So any questions? Like I'll take a pause, and because this is important to grasp. So if you are confused about anything at all, or you don't agree or whatever, yeah, feel free to ask, talk, offer opinions, etc.
This makes sense actually.
Okay, others are like either mind blown or yeah, I mean this is 101. Whichever way think about it, it's good. So now if with this knowledge, right, this is knowledge that we got because we started again thinking more about the problem domain and problem, right? So ultimately, if you think about grep, it is fundamentally a filtering problem. Does that make sense?
Yeah, it does.
Like you have bunch of, it's almost like imagine a filter, right? There is a the typical funnel wala jo filter hota hai. Imagine that there is bunch of input that goes into the filter, and bunch of thing gets there is a strainer, right? I think it is called, which is it keeps bunch of stuff inside it, and then only the good stuff goes down and is passed to the next sections of sorts. So what we are really doing with grep is actually filtering.
Yes.
So now what we need to think about, we have only like 7 minutes remaining, so I'll quickly try to conclude, right? So we have a filtering problem at hand. That's the fundamental nature of this grep problem. Then what we need to worry about is how do I get input to this filter and where does the output go? Currently in the first test case, we talked about getting input from a file, right? That's why we came up with the conclusion that yeah, our function signature is going to contain a file name or a file path. But now if we read the second test case, we are like, okay, actually, you know what, file is just a way of getting to the filtering problem. I could also filter from standard input, or I could also filter from, you know, you can imagine a next story in this that we haven't written yet, but I could easily write a next story saying read a TCP or a UDP or any socket, get the data from that socket and filter on that. There is no file, there is no standard input. It's a different third mechanism of accepting input, reading from a socket. The core functionality remains the same, right? Which is, okay, whatever we read line by line, we have to filter it out, right? The filtering problem still remains the same. It's how we get the input data, that mechanism changes. On one side it is file, on other side it is input string via STDIN, on third way it is like a TCP stream or UDP stream or what have you, right? Does this make sense?
Yeah, the source can change, but the core functionality will remain the same.
Yes, correct. And similarly, if you think about destination, right now we are printing, actually we haven't implemented that because we are returning the result. But imagine we said that, okay, we have to print this result to console. We could have easily written fmt.println match lines, right? But that printing also can change tomorrow. Like, okay, I don't want to print to console. I want to write it to a file, or I want to write the output directly to a TCP output stream.
Or I want to put it on some cloud storage directly.
Correct, right? Or I want to literally send it to a printer, like a physical printer.
Plug and play approach.
For whatever you want to do, like I want to send it that directly to the printer. Right. So what we need to identify is what is the core problem that we are solving, and this is what we identified after like these many iterations with test cases. If we are able to listen to the test feedback, we have identified that this is a filtering problem, and all the other things are just externalities, are just necessary evil that we have to deal with in order to write our program. And these are all the ways in which program can change tomorrow, right? But what will not change is the filtering part of it. Like, there will be obviously more options in which how you want to filter all of that, but the part that will vary is the core of the program is filtering, and the necessary evil, which is like the periphery, is how you accept input, where the output goes, how fast you can read the input, like is it batch or is it streaming, like all of that are non-core parts of the program. They will obviously have some influence on the design and the way you filter, but they are non-core. All right, so what I want to do is in the next call, we have multiple ways in which we can approach this. Right? One way is we only focus on test driving the core part and ignore the non-core, right? That means we only write test cases which for a function which accept a string, a single string, or a array of strings as an input along with the string to search, right? And then we don't even worry about where the string comes from. Like that's all non-core part. So we won't even probably test it using TDD or whichever way. It's really up to us, right? For this particular exercise, we can go and still try to also test that area, because again, the purpose of this whole programming session is to learn, right? So we should know if we ever want to also test the external factors, how do we test it?
So can it not it be said, but since we ourselves here would be implementing the input and output wale modules, unke hone chahiye test. But if we're using a third-party library for that, then it can be safe to assume that they would have the necessary checks in place.
Yes, correct. So what we definitely want to test is our core logic and core part, which is literally just like in this current program, it's just little like that if condition, line number 31 to 33. That is literally what is the main core of the problem. Rest of the things are just
खुदा पहाड़ निकली चुहिया सही में वैसा वाला केस है.
Yeah, and this is the pattern that you will see in almost every problem. And writing the test first or thinking hard about the problem, when people say like break the problem down, they actually like, this is what I'm talking about. Like you really identify and classify problems into various types of pattern. And this is one pattern that we have talked about, which is filtering problem. There are other kinds of problem which are scatter gather. Okay, again, just giving that word, which is basically map reduce in some ways. Like if you have heard about a term called map reduce, it's a scatter gather kind of problem. So you can try to identify in whatever code that you write, what kind of problem am I solving? Because then it's almost like those design patterns, but for these problems. Each of these problems have their own standard or very sorted solution that people have come up with. And it's just a matter of identifying what problem are we solving, what category it is, and then applying that solution to that problem. Cool. All right. So I think, yeah, we are already over time. So what we should do is next time, I think Rohan should drive this session. And what we can do is I'll send out some links to read, which will help the next session. Like it will be much more easier. That way we won't struggle with syntax. And we will do it two ways. One is we will only test the core functionality first. That is what we will do. We will refactor the existing code to just test the core functionality. And if we get time in the next session itself, we will try to test the non-core functionality also. In this case, the current test cases that we have, they test the core plus non-core functionality both. Right? So as someone suggested some time ago that, yeah, we probably should refactor this code to remove the file part into a separate function or move this comparing logic into some separate function, etc. So that is what we'll start with.
I would also like to know, how do you test this standard input?
Yeah, so I'll send out a link. So typically the logic is simple. So there is a interface in Golang and almost every other nicely designed language. Two of them that I know are like Java and Golang. Okay, nicely designed is probably too positive about a language, but IO framework, which is nicely designed in these two languages, they both have a standard interface abstraction to input output. So in Golang, it is called io.reader. You should read about that. And you can use io.reader to mock or to almost behave as if it is a standard input or a file or a TCP stream or anything. All of them can be abstracted under an io.reader.
Okay.
Similarly, in Java, we have I believe, what is it called? Reader or writer interface. They have a read and write method, and it's the same terminology, same fundamentals. Any type of input data source will be abstracted by a reader. Any type of output data source, by output data source, I mean any screen or print fmt.println or printer or TCP output stream or file or anything will be abstracted by a writer interface. So using these two, we can mock of sorts or stub the STDIN and STDIN, and we won't, and that way we will still be able to write automated unit test by where the input is still STDIN.
Okay.
Like we won't have a manual person entering some data and then like test cases running. No, it will be simulate that entire behavior. Again, this is where the power of abstraction comes into picture, and identifying the right abstractions is the key. All right. Okay, I think, yeah, that's it for today's call. Thanks, Suraj and Mohit, both of you, for presenting.
Thanks.
I would say, yeah, next
Thank you.
time, Rohan, it's your turn, and I'll send out some links for us to read.
Okay.
Okay, thanks. Bye.
Thank you.
Bye.
Bye.